Hello, my name is Peter Levy from the Centre for Ecology and Hydrology in Edinburgh, and I'm going to tell you about a project called Landscapes for Sequestering Carbon, which is in the UKRI Landscapes Decisions programme. Okay, the motivation for this project is that the UK is committed to net zero emissions of greenhouse gases by 2050, as I'm sure you know. Now, the reason it's called net zero is that we envisage that there will still be some gross emissions of greenhouse gases, but we'll need some mechanism to sequester those emissions. Land use change is one potential way to sequester carbon, for example by afforestation or converting arable to grassland. Both of these result in an increase in the carbon stored in terrestrial ecosystems. However, these carbon benefits are not reflected in the market prices. It's a so-called economic externality, and that means that land use decisions that people make on the ground don't account for these carbon benefits. Marginal Abatement Cost curves, or MAC curves, are an economic tool for reducing pollution in some kind of economically optimal way. To construct these, we need to estimate the true cost of pollutant damage and the marginal cost of all the different abatement measures. This lets us prioritise measures in order of their cost effectiveness. For example, afforesting rough grazing land is probably a lot more cost effective than afforesting good arable land. And we can compare that to the cost effectiveness of converting arable land to grassland. However, there's a serious complication in applying this to land use change, in that land is a finite resource, so an increase in one land use means a decrease in some other land use. In other words, every land use change has several opportunity costs. That is the cost of not doing agriculture when you were doing forestry, for example. And the other aspect is that land varies in quality. So you can imagine that every 1 kilometre square in the UK has a different potential for forestry, for grazing, and for crop production. So in effect, there's a unique MAC curve for every 1 kilometre square in the UK. And this project is building on previous work that we did, which developed a method for estimating land use change given a whole range of data sources using a sort of data assimilation approach. So in this project we use the same method, but we use it in forwards mode to predict future land use change rather than estimating past land use change. So we start with a map of current land use, and then we can model the probabilities of all land use changes in each grid square, and with their associated carbon sequestration that you get from that land use change, and the market cost of making those land use changes. We do this in a Bayesian way, so we simulate thousands of possible land use changes probabilistically. So to cut a long story rather short, this produces a national scale MAC curve with uncertainty, which accounts for the spatial variation in land quality and includes all the opportunity costs of the lost land uses. So this is still work in progress, and I'll be showing results in future meetings, but for now, thanks for listening, and any questions, please send them to the email address below. Thanks.